Hey guys, I had a request to not have the little video along with it, so let me know what you think. Comment down below if it's easier with or without the video, having someone to follow along as you watch these lessons. Today's section is on triangles, so we're looking at angles again, but in relationship to triangles. So let's talk about a few things that you need to know about triangles. First of all, some vocabulary to review. First, a line segment is a part of a line that contains two endpoints and all the points in between. For instance, this is a line segment. It's not a whole line. Lines continue indefinitely, actually. So anytime we cut off a line with two endpoints, that's called a line segment. A triangle is formed by three line segments. By the way, this is on page 393 in your books if you want to follow along and take your notes there. Page 393. A triangle is formed by three line segments that intersect at their endpoints. The point where the segments intersect is called a vertex, and these three angles that lie inside a triangle are called interior angles. So first of all, we have sides, and we label it with a little line segment at the top. So this is segment XY, segment YZ, segment XZ. Then we have our vertices, X, Y, Z, and then our angles, angle X, angle Y, and angle Z. Now with triangles, we'll label it triangle XYZ. With angles, we can label this angle a few different ways. We can call it either angle Y, or angle XYZ, or angle ZYX. So you can label the angle with just one letter if it's easy to figure out, or you might have to sometimes use all three letters, but the vertex is always in the middle of those three letters. So XYZ or ZYX, you can call that. But the sum of the measures of the angle in a triangle has a special relationship. So you guys watch this and you'll learn about
Angle sum of triangles. The interior angles of any triangle have a special relationship. We can demonstrate the relationship by first tearing off each corner, or angle, of the triangle. Arrange the corners so they meet at one point. Notice that the angles create a straight line. This means the sum of their measures equals 180 degrees. Let's examine another triangle. Use a protractor to measure and label the interior angles. The sum of the measures of the angles is 180 degrees. Tear off the corners and fit them together to confirm they create a straight line. This demonstration shows that the sum of the measures of the interior angles of a triangle is 180 degrees.
So that's important to know, is that the sum of the measures of all three angles for any triangle will always add up to 180 degrees. So if you want to find the missing angle, if you know two angles in a triangle and you want to find the missing, so here's a triangle, the red part here, we want to find the value of x. So this angle is 56, this one is, what does that mean? 90 degrees, and we want to find the missing angle. Well, we know that all three of those angles together have to, where did it go? Oh, okay, sorry. So all three of those angles together, x plus 56 plus 90, has to equal 180 for every triangle. It's always that. So now you're just solving this simple equation. Combine like terms, subtract 146, and you get x equals 34. So the measure of that angle is 34 degrees. Really, really basic for that part. But some of these get a little tricky because they don't give you the actual measure, but in this case it says that the measures of the angles are in the ratio 1 to 4 to 5. So that means, like, for instance, if this angle was 10, then this angle would be 40 and this angle would be 50. That doesn't work because those measures don't add up to 180, but that's kind of what that means if you understand that. So if we want to do this, we don't know the exact measure of the first angle, but we know that they all add up to 180, and we're going to call the first angle x. So if the first angle is x and the next one is 4 times greater, then we could call the next one 4x and the last one 5x. And so using that information, we can write an equation. X plus 4 times that angle plus 5 times that angle, all three of those angles together have to equal 180. So this is still not a super difficult problem to solve if you're given the ratios of the angles. So then solve this equation, combine like terms, 10x equals 180, divide by 10, so x equals 18. So that means that the first angle of that triangle is 18 degrees, and the next one would be 4 times 18, and the next one would be 5 times 18 degrees, and all those together will add up to 180 degrees. So those are the inside angles of a triangle. There's another angle of a triangle called the exterior angles. And exterior angles are formed if we extend the sides of the triangles. So 4, 5, and 6 would be exterior angles. And you could see that any interior angle plus its exterior angle have to add up to 180 degrees because they form a straight line. So those would be supplementary to each other. Now with exterior angles, and again there are some places in your notes, so make sure you're filling in all the blanks here. Each exterior angle has what we call 2 remote interior angles. So not the ones next to it. So for instance, 5 or angle 4, the 2 remote interior angles would be 2 and 3. So not the one right next to it, but the other 2. And so 5, what do you think are the 2 remote interior angles for 5? Right. So not the one directly next to it, but the other ones. And for 6, 1 and 3 would be the remote interior angles. So each exterior has 2 remote interior, and there's a relationship between those. So watch this video and let's see what that relationship is.
Exterior angles of triangles. An exterior angle of a triangle and its 2 remote interior angles have a special relationship. To examine this relationship, we'll first measure the angles of the triangle. Measure and label the interior angles.
By the way, this is 398 and you can fill in the blanks there.
Next, measure and label the exterior angle. You know that the sum of the measures of the interior angles is 180 degrees. You also know the sum of the measures of supplementary angles is 180 degrees. Since both of the equations equal 180 degrees, we can set them equal to each other. To simplify the equation, subtract 65 from both sides. The resulting equation is 60 degrees plus 55 degrees equals 115 degrees. Notice that the sum of the measures of the 2 remote interior angles, 60 degrees plus 55 degrees, is equal to the measures of the exterior angle, 115 degrees. This relationship is true for any triangle. The measure of an exterior angle of a triangle is equal to the sum of the measures of its 2 remote interior angles.
So there's your relationship there. The measure of an exterior angle is always equal to the sum of the measure of the 2 remote interior. So angle 1 here is equal to the sum of angles A plus B. So A plus B equals the measure of angle 1. And that's true for any triangle as well. So let's look at an example of finding angles. And again, you should be trying to check problems after each example as you're going here. So here's a beach chair. The measure of angle 2 is 55, angle 3 is 60. What's the measure of angle 1? Well, here's an exterior angle, and these are both remote interior angles. So exterior, 2 remote interior, which means that 2 plus 3 equals 1. So 55 plus 60 is the measure of angle 1, which is the same number as the last problem, 115 degrees. So So the measure of angle 1 is 115 degrees. So you can always find an exterior if you know the two remote interior angles. All right, let's look at another example. Angle 1, we know that 2 and 3 are 75 and 30, so 75 plus 30 is the measure of angle 1. So angle 1 has to be 105. It's the sum of those two. Are you guys liking geometry yet? All right, angle 4. So now we have to work our way around. This is 90 degrees. Angle 4 is 135 degrees. So think about this. If this is 90, then 1 plus 2 has to be what? Angle 1 plus angle 2 have to also be 90 degrees, don't they? Add up to 90 degrees. But let's look at this. Angle 4 is equal to these two angles together. This angle plus this angle, and we know this one's 90 degrees. So angle 2 plus 90 degrees equals this remote exterior angle 4. So angle 2 has to be 45 degrees, which means that angle 1 ends up also being 45 degrees. Now, does it say? It doesn't say anything about angle 1. Huh, interesting. Okay. So yeah, 1 and 4 are supplementary. Oh, okay. There we go. So theirs is also 45. But also, if this is 45 and this is 90, this also has to add up to 45. So use that, the fact that they all add up to 180, the exterior adds up to those two, and that's the main thing in this section. So try all those check problems, and we will practice this in class tomorrow, or no, actually Thursday, depending on whenever you watch this. So Thursday in class, we'll try some of these.